The next part of our lecture is how to calculate the lateral earth pressure on a wall. We have, of course, using our equation that was given here. We took this equation and we say, here is the equation. Where is it? This is our equation, and we said that we can use this equation for C5 soil, and there is something called H crack that we need to calculate in case of having a C5 soil. So I will give you a wall. This is a wall. How can this is a wall. I want to solve this wall. What is this wall? I have three soil layers. Soil 1, soil 2, soil 3. Soil 3 is on both sides. So of course, if I have three soils, then I will give you C and phi, and I will give you all the parameters of the phi, or you will assume it in case you have a coursework. Then you will have to assume what is the value of C and what is the value of phi based on correlations with other parameters that you will be given. So these are the three layers. It means that if I apply the equation, let's just remember what was the equation. This is the equation. In this equation, there is C that is given directly, and there is phi that is given indirectly in case of sigma vertical. So I have C and I have phi in this equation. So I will have C and phi for this layer. It starts from this level till this level. So if I go 1 centimeter above, I have a C and phi. If I go 1 centimeter below, I have a different phi. It means that will 1 centimeter affect the value of C and or the value of the depth? No, it's the same depth. If I have here a depth of 2 meters, it means that 2 meters minus 1 centimeter is also 2 meters. 2 meters plus 1 centimeter is also 2 meters. It's nothing. So at a depth of 2 meters, I have two values. One just above and one just below. So it means that at the interface between layers, I have to calculate the value twice. One at the bottom of the layer and one at the top of the next layer, because I will have different C and phi. Okay, this is the first thing you need to understand. If I have a level of water, it means that above the level of water, I have gamma soil, which is gamma bulk, saturated. But if I go below, then I will need to use, you remember what we said in the previous year, effective and total stresses. I will need to take the effect of water from the effect of soil. So it is related to the effective and the total. Why? Because I have here two problems. What are these two problems? As we said, if we have water, we need to study the effective stress. But we said that water also have horizontal pressure, and this will affect the wall. So it means that I can ignore the effect of water. Why? Because it is acting, and use the total. You can tell me this, but it's not always the case. Why? Because if groundwater table is here, so it is here in one side and it is not here in the other side. So this is my problem, is that I may have a triangle resembling or showing the effect of water from one side and another triangle from the other side, and they are both cancelling each other. But if the triangle starts from a higher level, then I will have two triangles, one very big triangle, one very small triangle. So because of the effect of the change in the level of the groundwater, then I will have to calculate water separately. So I will, if you have water level that is the same on both sides, ignore it. Why? Because whether you put it or you don't put it, it will be the same. But I will not consider this. I will go to a general rule. I will take water alone and effective stresses of soil alone. This will be the general rule that we will use for all cases. If I have groundwater table, then take the water alone, because the water is a little bit complicated. It's not that straightforward. Take it alone and continue your problem considering the effective stress. It means that use here gamma bulk, which is gamma saturated, and here use gamma submerged, which is gamma soil minus gamma water. So in this case, you will solve the problem for two cases. For the case of soil, effective. And for the case of water, alone, because you may have different levels. If you have the same levels, then both triangles will cancel each other, and I don't need it. But this is just the general rule. Please use this general rule. So what are the points that I'm going to calculate? I'm going to start with the surface. This is the top of soil layer number 1, and point number 3, this is the bottom of layer 1. Point number 4 and point number 5, top and bottom of layer number 2. Point 6 and point 7, top and I can say bottom, but it is not the bottom of the layer, it is the end of the wall. I don't want anything below the wall. So I will calculate at 6 and 7. There is a point which is 2. In point 2, I calculated values. Why did I calculate value? Because this is the start of groundwater. So this will be the top of the triangle for the water. So I need to calculate at this point. But I don't want to calculate above and below. Above and below is all at layers, start and end of a layer. But if I have groundwater in the middle of the layer, then I will calculate once. All of these are active. If I go to the other side, it will be the passive. In this case, for the passive, I have 0.8 and 0.9. I don't have anything. Water table coincides with the top, so I don't want. If water was here, then I was going to calculate at 8, 9, and I will add another point here in the middle. It will be 10. Usually, if you are calculating below soil and you have something here and something there, it is better to have values on both sides. If you need a value here, then you will have to, you need to know the other value on the other side. This will be for the ease of calculations, not a must. It's for the ease of calculation. Here I did not calculate anything because I know that the pressure here on the other side, here this is the active side. What is the passive pressure at 1 and the passive pressure at 2 and the passive pressure at 3? Zeros. So I don't need to calculate them, I know them. Okay, I have an example. A vertical smooth wall. What is the importance of saying a vertical smooth wall? It means that I can use my equation. It's not. It will not affect anything, but it will affect me if I have different equations and I need to know which one to use. If I have a vertical smooth wall, then I will use my equation. But if I tell you that it is an inclined rough wall, then you will have to search for another equation. Of 6 meter height, supports sand backfilling. So it is sand. From the text, you will get values. sand, it means that C equals to 0. Oh. Sand backfilling with horizontal surface. Horizontal surface means that I can still use the equation. And of course, if it is phi sand, then I can use the equation. Because if I tell you that it supports clay, then you will tell me, no, I cannot solve this problem. Compute the active earth pressure assuming water table to be at a depth of 2 meters below the backfill surface. He gave me phi 32, gamma, this is gamma bulk 1.8. If I need to calculate the effective unit weight, it will be 1.8 minus 1. It will be 0.8. If the soil and water level in the other side is above the wall footing by 2 meters, calculate the passive earth pressure. I need to go to my problem. This is the problem. This is the wall. This is the surface here and the surface there. This is the groundwater here and this is the groundwater there. Of course, you have a different in groundwater. So I will need to calculate at specific points. But before going into specific point, in this problem I have an inclined surface. It's not vertical. So the approximation I will have to do is to assume as if this line is vertical, it's not inclined. Because usually if I have inclined surface, then the pressure will be vertical on this. Oh no, I will not consider this. I will consider as if this part of the soil is part of my wall. It's an approximation and it is acceptable. It's not a very big approximation. So I will just go to this point and will start to calculate. This is my K active, 1 minus sine phi. Here is the correct equation for K passive. K passive is 1 over K active. So it means that 1 minus sine phi will go below and 1 plus sine phi will go up. So this is the equation, because usually you will calculate K active, and once you get 0.13, so K passive is 1 divided by 0.13. That's all. And this is the equation I'm going to use for sigma active, and I will start calculating sigma active 1, which is at this point, sigma active 2, which is at this point, sigma active 3, which is at this point. At this point, it is 0. I don't have anything. I don't have C to get a value, and because the soil is phi, and I don't have H to get any effect for the phi. I will go down to this point. At this point, I will take gamma as it is, because all of this is above groundwater table. So I will take it 1.8, and I will take a depth of 2 meters. And I will take, this is sigma active, and I will calculate everything till this point. So point 2 is okay. Once I start going into point after point 2, what will change? What will change is the value of gamma. Instead of being 1.8, it will be 0.8. So if I tell you calculate here what is the active pressure, the active pressure, it will be 2 multiplied by 1.8, which is the top layer, it's the same law, plus 4, which is this length, multiplied by 0.8. So this is the vertical, multiplied by K active, you will get the value. So I will remove gamma water. So this end up, this active, I will go to the passive. I need to calculate 0.4 and 0.5. For the passive, I will use a different equation. The difference is in the sign. It is here plus. Of course, you don't have a problem because you don't have C. It will be different in other problems, in other examples. If I give you a value of C, you will find that instead of being here plus 0, and in the other case it was minus 0. Plus 0 and minus 0 are the same. But if I tell you plus 5 and minus 5, there will be a difference in the equation. So for the passive in the other direction, it's only because of the effect of the vertical force or the vertical stress. So here it is 0, here it is a value, and so on, and I can continue. If you want to, we will stop here, but if we want to add something to this problem, I will tell you, take the C equals to a certain value. So you will start applying in this equation, you will get different values. What are these different values? We are going to discuss it later. But so far, we draw only what, this is important. I was going not to say it. This triangle and this triangle are the effect of soil. Where is the effect of water? We did not take it into consideration. We have to take it into consideration. What is the effect of water? At this point, this is the start of the water, so it is 0. If I go down, then I will have a value of, I went down 2 meters. So 2 meters multiplied by gamma water, which is 1, so the stress will be 2. I have here 2 options. Please concentrate on this because this is very important. I can do two things for the effect of water. I can continue with this triangle till the bottom. So here it is 2. I go to 0.3. 0.3, the height is 4. So instead of having a value of 2, I will have a value of 4. So I have here a triangle with a value of here 0, here 2, here 4. I will go to the other side. I will start drawing here another triangle. This is the start of water. It is 0. I will go down 2 meters. Then I will have a triangle from 0 to 2 meters. You have here a big triangle, and opposite to it a small triangle. You can subtract both or work having both, the right and the left. In this example, I just subtracted. Here you had a triangle from 0 to 2. It was supposed to be here 0 and here 2. There was a triangle, a small triangle here. I just subtracted this triangle. So this is the net effect of water. This is what I need to concentrate on this lecture, how to calculate the horizontal stresses at all points due to soil, and how to add the effect of water, either having 2 triangles or 1 net triangle. That's all for this lecture. Next week we will continue the remaining of the lecture. Thank you.